We're live.
Hi, so our CPE 133 final project is called a binary puzzle, and it's by Lauren Price and Nick Short. So basically, our binary puzzle is a game played by whatever individual uses the board. So we begin with a question, you could say, or a 2-digit displayed on the last 2 digits of the 7-segment display. Now you know if this number is hexadecimal or decimal by the last 2 LED lights on the board. The individual takes that number and tries to do the equivalent binary number using the last 5 switches on the board. After the individual creates what they think the binary equivalent is, they press the middle button on the board, which indicates as an enter button. If correct, it will add a point to the score, which is indicated in the first 2 digits of the 7-segment display. If incorrect, it doesn't add any point to the score, but it still continues to the next question. After answering the 10 questions we provided, the game is over. The final score is shown on the first 2 digits of the 7-segment, and the individual is able to switch the reset button, which is indicated on the first switch of the board.
So our top level, otherwise known as our driver file, is the entire makeup of our whole project, consisting of 4 submodules, a 4-bit register, a number select decoder, a check decoder, as well as a 7-segment translator. Our 4 inputs are the verify button, the reset switch, as well as the 5 switch bits used for the user input. And the outputs are the decimal LED indicator, the Q value, which displays the question values in the anode and cathodes for those on the 7-segment display, the score value and its anode and cathode correlation values, as well as the hexadecimal LED indicator. Our first module is the input decoder, which is a 10-state finite state module. It takes in a 4-bit state input, as well as a base clock, the reset, and verification buttons. And the resulting outputs are a 4-bit state out button, a hexadecimal and decimal output for the LEDs that are used in the top level module, as well as the 2 number values for the question that is being asked. As shown in the schematic below, you can see all 10 states are being represented, and the multiplexer indicates the outputs of the 5 switch of the state input.
Our second submodule is the check decoder. The check decoder has 9 input values, 8 of which are 1-bit inputs, and 1 of them is a 4-bit input. So our inputs are the in, which is the correct answer to the question, the enter button, the clock, the reset switch, and then the 5 switches the individual uses to convert to the binary number. And then our output is the correct number, which is a 4-bit output. So what our schematic shows is it takes the 5 switches that the individual enters as the binary number, and it takes the correct binary number. It compares the 2, and then it outputs the correct number. If the binary number is valid or correct, it adds 1 point to the score. If not, it continues to the next question. Our third submodule is a 7-segment translator. So this translator has 4 inputs, 3 of which are 4-bit inputs. 1 of them is a 1-bit input. So our inputs are the clock, Q1 and Q2, which is the first digit on the question, you could say, or the last two segments on the 7-segment display. So Q1 is the first digit, Q2 is the second digit. And then our last input is the correct value. Our outputs is the 7-bit cathode, which is all the segments on the 7-segment display, and the 4-bit anode, which is indicated below.
And our final module is a 4-bit shift register, which just consists of the input number that is being put through for the question and outputting the verification of that number using 4 D flip-flops. The D flip-flop modules were combined together to have the verification on the clock signal, as well as to allow the R value or the reset, so that if the reset switch is initiated, the output can be reset instead of moving on to the next question. This project came with quite a bit of successes as well as quite a bit of hardships and failures in a way. The biggest successes is obviously having the project come together and have it work, as well as having one of the most important modules, the shift register, just coming together super quickly because it's been used from previous labs. But these ideas didn't come easy. We went through a series of different projects and we kind of made a consensus to do something that was both fun, challenging, but also something that would be understandable for the users that we're making it for. So by creating the 2 decoders and the 7-segment translator, that required kind of a bit of research as well as a lot of discussion to figure out how we were able to do that correctly. And it came out, I think, in the best way possible that it could have, but it took up by far the most time, and the most complicated processes were definitely for those 3 modules. And now we have our verification and its functions. And that is the completion of the entire project. Thank you.
Thank you.